All right, let's continue with our discussion on AI ethics. So first of all, let's look at the one important proactive security practice where team adopts an adversarial approach to test AI systems for robustness, security, and reliability. Inspired by military strategy, red teams simulate attacks to uncover vulnerabilities before malicious actors exploit them. The um, the objective assessment of thinking like an adversary. So red teams critically assess AI systems by identifying weakness that attackers might exploit. For example, we can test an AI fraud detection system to see if it can be tricked into approving fraudulent transactions. So we can apply diverse techniques to use in red teaming. First one is adversarial attacks. We can test AI models against manipulated input designed to fool them, such as creating adversarial images that cause misclassification in computer vision models. Second, security audits and penetration testing. We can conduct in-depth AI infrastructure assessments to identify vulnerabilities, such as evaluating how well an AI chatbot handles malicious prompts. Third, perform ethical hacking to improve AI security. So ethical hacking systematically tests AI models without malicious intent, such as attempting to extract sensitive training data from an AI without actually misusing it. So the goal here is to report vulnerabilities rather than exploit them. First one is adversarial machine learning and attack AI to strengthen it. Techniques include invasion attacks to fool AI into misclassifying inputs, poisoning attacks by injecting corrupt data into training datasets, and extraction attacks by reconstructing AI models by querying them repeatedly. Fifth one is bias and fairness evaluation and ensure ethical AI. So red teams assess AI for biases to ensure fair decisions, such as checking whether AI hiring tools favor one demographic group over another. Six, robustness and reliability testing. AI models should handle unexpected inputs and real-world challenges, such as testing a self-driving car AI in low light or extreme weather conditions. Seventh technique is iterative process and continuous improvement. Red team is not a one-time exercise. So because threats involve and AI systems must adapt, um, we need to do periodic red team assessments to ensure defenses remain effective and collaborate with red teams, with blue teams here. So red team work with blue teams. These are a group of AI developers and security experts to understand AI design and intended use and prioritize security fixes based on risk levels. Next is to do documentation and knowledge sharing, documenting attack methods, vulnerabilities, and defensive strategies helps improve AI security across industries. For example, publishing we can publish research on how AI models resist adversarial attacks to benefit the broad AI community. So red teaming is a critical part of AI security by anticipating how attackers might exploit AI and addressing weakness before they can be used maliciously. We can build more trustworthy, resilient, and secure AI systems. Next, we will discuss about ensuring fairness in AI systems. It is critical to prevent discrimination and mitigate biases that could lead to unequal treatment based on race, gender, age, and other characteristics. AI fairness measures aim to evaluate and improve equality in AI models across different groups. First, let's look at fairness definition and how do we define fair AI. So it includes factors such as demographics parity or statistical parity. It requires that decision outcomes do not depend on protected attributes such as gender and race. If a long AI approves 20% of male applications, it should approve 20% of female applications. And equality of opportunity. Individuals who qualify for a positive outcome should have equal chance of being correctly classified. For example, a medical diagnosis AI must provide equal accuracy for all racial groups. Next is equalized odds, which extend equality of opportunity by ensuring equal false positive and equal negative rate across different groups. For example, in hiring AI, false rejections should not be higher for any demographics group. And we also need to create bias detection and assessment tools. These tools provide metrics and algorithm to assess fairness and suggest bias mitigation strategies, and pre-processing techniques to fix bias before training, such as data rebalancing and reweighting. So data rebalancing adjusts dataset to ensure fair representation, and reweighting modifies instance weights to minimize bias towards any group. Next technique is in-processing techniques to ensure fairness in model training. It includes regularization method and adversary debiasing. Regularization method add fairness constraints during training, and adversary debiasing trains an AI model to minimize its ability to predict protected attributes. Next techniques is post-processing techniques that adjust model output, such as modify decision threshold for different groups to equalize outcomes and ensure AI models do not disproportionately favor one group over another, and transparency and explainability to make AI fairness understandable. So that focus on explainable AI or XAI, which helps users understand AI decisions and identify fairness issues, such as hiring AI should explain why a candidate was rejected, and continuous monitoring and evaluation. Fairness isn't a one-time fix. AI models must be monitored over time as they interact with new data. And then we also need to engage stakeholders to ensure inclusive AI development. We need to involve diverse perspectives and ensure fairness is defined and applied holistically. For example, we need to engage ethicists, civil rights organizations, and affected communities and marginalized groups that have been traditionally overlooked. So achieving fairness in AI requires a mix of technical, ethical, and regulatory approaches. By carefully curating data, designing fair models, and continuously monitoring AI systems, organizations can build AI that is not just effective, but also equitable and just for all individuals. So let's look at AI alignment, which is the process of designing AI systems that reliably pursue human goals and values. This objective is to ensure that AI behaves ethically, safely, and beneficially, even in unforeseen situations not explicitly programmed by developers. So why is AI alignment important? First, it prevents unintended consequences. Powerful AI systems can cause significant harm if their actions conflict with human values. And it also avoids existential risks. If AI optimizes for unintended goals, it could lead to dangerous or uncontrollable outcomes. For example, AI optimizing for efficiency in resource use might prioritize cost saving over safety, leading to harm. Second, there are many challenges in AI alignment, such as defining and formalizing human values. So translating complex human goals into machine-readable instructions can be difficult. And fairness can mean different things in different contexts. How should AI interpret it? And we need to prevent AI from deviating over time. AI systems must remain aligned even as they adapt and learn in new environments. A self-driving car should not sacrifice safety in pursuit of efficiency as it might encounter new traffic patterns. So key approaches to AI alignment include value alignment, corrigibility, and robustness to distributional shift, and ensure interpretability and explainability, and perform reward engineering. Now let's look at each one of them separately. First, value assignments. We need to teach AI to internalize human values rather than just optimizing for a predefined goals. We need to train AI assistants to prioritize ethical decision-making over purely maximizing efficiency. Second, corrigibility. is about designing AI to accept human intervention and correction without resistance. If an AI system misinterprets a task, it should allow human operators to override and correct it. Third, robustness to distributional shift. And we need to ensure AI remains aligned even in new and unexpected situations. A medical diagnosis AI should not make dangerous assumptions when encountering unfamiliar diseases. AI models should be understandable and transparent so human can trust and audit their decision. AI decisions in criminal sentencing or hiring should be explainable, not black box outputs. And reward engineering is about designing AI reward functions that encourage ethical and aligned behaviors. Instead of rewarding an AI chatbot only for engagement, it should also reward it for truthfulness and helpfulness. So AI alignment is essential to ensure AI remain safe, beneficial, and aligned with human values. By integrating value alignment, corrigibility, interpretability, and robustness, researchers aim to create AI systems that reliably act in our best interests, both today and in the future. So AI alignment ensures that AI goals, decisions, and actions remain in harmony with human values and intentions. Super alignment takes this further by focusing on achieving highly reliable alignment for advanced autonomous AI systems that could have significant real-world impacts. First, let's look at objective function optimization that aligns AI goals. So as we discussed, it's about reward engineering, and also it's about constraint optimization. So reward engineering is about carefully designing reward function to reflect ethical considerations. And constraint optimization is about incorporating ethical constraints into AI objectives, such as a self-driving AI should prioritize pedestrian safety over reaching destination faster. Next technique is inverse reinforcement learning that learns from human behavior. AI observed human actions to inform underlying preferences and values. So AI learn ethical behaviors from how humans resolve moral dilemmas rather than relying on predefined rules. Next technique is iterative or iterated distillation and amplification, IDA. Iterated distillation and amplification, IDA, which is about scaling human oversight. So a process where IDA is a process where simpler AI models learn from more complex models under human guidance. For example, a medical AI is iteratively refined by doctors providing oversight at each step. Next technique is human feedback integration which keep AI in check. So we have reinforcement learning from human feedback, RLHF. These are the AI systems that adjust behavior based on direct human input. So, for example, human rate AI-generated responses to ensure ethical decision making, and active learning for AI to ask humans for guidance on uncertain or morally ambiguous situations. For example, AI seeks inputs on ethical decisions in self-driving scenarios. And next technique is value learning and teach AI human ethics. So AI learns human values by interacting with human and adapting to cultural contexts. For example, a global AI assistant can adapt its responses to different cultural norms and causal inference that understand causal and effect. So AI models analyze cause and effect relationships to predict the impact of decisions. AI evaluates health policies and ensure it minimizes unintended side effects. So AI alignment and super alignment are crucial for ensuring advanced AI systems act in humanity's best interest by integrating human feedback, value learning, constraint optimization, and causal inference. We can develop AI that remains trustworthy, ethical, and beneficial across all scenarios, even those we haven't anticipated. So next technique is robustness and uncertainty modeling to handle uncertainty in AI. So it's important because AI must recognize when it's unsure about its decisions. So we can use techniques such as Bayesian method to model uncertainty. We can do out-of-distribution detection to identify unfamiliar scenarios. For example, AI in autonomous driving should slow down when uncertain about road conditions instead of making an unsafe decision. Transparency and interpretability to make sure AI decisions are understandable. So alignment is easier when human can verify AI decisions. Techniques include explainable AI to provide clear reasoning for AI decisions. So a technique such as chain of thoughts, which is adopted in modern day state-of-the-art AI systems. So for chain of thoughts is about break down the decision-making process of AI system into single steps. So, and then allow AI system to output each steps of the reasoning process. So that will give human insight about how an AI system make a decision, right? So that is a great step into making sure our AI models are transparent, interpretable, and explainable, right? So chain of thought is a prompt engineering technique used a lot in large language models to improve their reasoning capabilities by explicitly guiding them to generate intermediate reasoning steps before arriving at a final answer. This approach helps the model break down complex problems into manageable parts, improving accuracy and interpretability. So there are key features of chain of thought prompting. One is step-by-step reasoning, and prompts the model to articulate its reasoning process in natural language, leading to a structured and logical progression towards the solution. And by focusing on intermediate steps, COT reduces errors in tasks requiring multi-step reasoning, such as math problems, logical puzzles, and common sense reasoning. And COT can also be applied to various domains without requiring fine-tuning. Making it a flexible tool for enhancing large language model performance. And there are different techniques such as zero-shot chain of thought that includes simple instructions like let's think step by step to guide the model's reasoning. Few-shot COT by providing a few examples of reasoning steps in the prompt to demonstrate how to solve similar problems. And self-consistent COT runs multiple COT prompts and select the most consistent answers among them and improve reliability. And automatic COT that automatically generate reasoning demonstrations by clustering questions and sampling diverse examples from a data set. Next is ethical and philosophical modeling and embed morality in AI. So AI systems must navigate complex ethical dilemmas. So we have techniques such as rule-based ethical frameworks, hybrid AI-human decision models to apply human values in real-world situations. In AI debate and argumentation to explore diverse perspectives, AI should evaluate different ethical viewpoints before making high-stakes decisions. So we have techniques such as AI debates that generate structured argumentation between AI models, supervised by human judges to determine the most aligned responses. So there are a lot of ongoing challenges of the super alignment, such as technical and ethical complexity. So aligning AI requires advances in machine learning, ethics, philosophy, and governance. And also there's concerns about cultural and value diversity. Ethical AI systems value across cultures, making universal AI alignment difficult, and cross-disciplinary collaboration. And AI safety requires input from engineers, ethicists, policymakers, and society at large. So super alignment is a continuous effort as AI systems grow more powerful, and we need to ensure they act ethically, safely, and transparently. And these are becoming increasingly critical. By integrating uncertainty modeling, ethical reasoning, transparency, and debate, we can build AI systems that respect human values and serve humanity responsibly. So now let's go a little bit deeper into this AI explainability and interpretability. So these are critical for trust, transparency, and accountability in AI systems, especially in high-stake domains like healthcare, finance, and criminal justice that impact human directly. This concept helps users understand how AI models make decisions, ensure they remain reliable, ethical, and regulatory compliant. So what's the difference between AI explainability and interpretability? AI explainability provides insight into why an AI model behaves a certain way. And AI interpretability focuses on making the model's decision-making process understandable to human. So AI explainability and interpretability is important because they improve trust and transparency, and ensure accountability and regulatory compliance. Some industries like finance, healthcare require AI explainability before they can be deployed. And techniques for AI explainability and interpretability include visualization, feature importance analysis, decision tree and rule extraction, and model agnostic methods. So visualization, such as graphical representation, help users see patterns and relationships in data. And feature importance analysis identify which input most influence the AI decision. And decision tree and rule extraction provide human-readable decision logic. And model agnostic methods such as LIME and SHAP. So LIME here stands for local interpretable model agnostic explanations. It explains individual predictions by creating simpler surrogate models. And SHARP stands for sharply addictive explanation. So it assigns important scores to each feature based on its impact on the prediction. All right. So, for example, local interpretable model agnostic explanations is a popular technique in explainable AI, designed to interpret individual predictions of black box machine learning model. So it's an algorithm that explains the prediction of any machine learning model by approximating it locally with a simpler and interpretable model. The name reflects its key characteristics, such as local. It focuses on understanding the model's behavior around a specific data point. And it uses simpler models, such as linear regression or decision tree, that are easy for humans to understand. And it's model agnostic. It can be applied to any machine learning model without requiring access to the internal structure, such as neural networks, ensemble models. So it works in a way that first we need to select an instance to explain and choose the specific data point for which you want an explanation. Then we perturb the data. We generate synthesized samples by perturbing the features of the selected instance. For tabular data, the tabulation may involve sampling from a normal distribution. For text and images, This could mean removing words or modifying pixels. We can make predictions on perturbed data. We can use the original black box model to predict the outcome for these perturbed samples. So we can perturb the data, and we can also make predictions on this perturbed data and use the original black box model to predict the outcome. And then we can weight samples by proximity and assign weights to the perturbed samples based on their similarity to the original instance using a proximity kernel. Then we can train a surrogate model, fit a simpler interpretable model such as linear regression on the weighted perturbed dataset. This surrogate model approximates the behaviors of the black box model in the local neighborhood of the selected instance. Then we can interpret the surrogate model, the coefficients and structure of the surrogate model provide insight into how each feature contributes to the prediction for the selected instance. So it works with any machine learning model. So that's why we say it's model agnostic, and it provides intuitive explanation for individual predictions. And it can handle different type of the data, such as tabular, text, and images. But its limitation is explanations can be unstable and sensitive to perturbations. And it relies on user-defined parameters like proximity kernels and feature selection strategies. And it only provides local explanations and does not capture global model behaviors. So we can look at an example use case to explain text classification. For a sentiment analysis model predicting negative sentiment for I like this movie, or I hate this movie, perturbation might involve removing words like hate or movie. The surrogate model identify hate as having the highest negative impact on sensitive. So for a long approval system predicting rejections based on income and credit score, so perturb income and credit score values around their original values. A linear surrogates model shows that low income has a strong negative impact than credit score. So LIME provides interpretable insights into black box machine learning models by approximating their behavior locally with simple surrogate models. It's widely used in explainable AI applications across industries like healthcare, finance, and marketing to enhance trust, fairness, and transparency in AI systems. So for SHARP methods, it assigns importance score to each feature based on its impact on predictions. So these methods explains the output of machine learning models. It provides interpretability by assigning importance value to each feature in a model's prediction. So It's also like line method. It's also model agnostic, and it's consistent by providing reliable explanations regardless of the model studied. It has high local accuracy, and it can accurately interpret the model's prediction for a given input. And it has additivity, added. The contribution of each feature can be computed independently and summed. So it first select an instant to explain and perturb the data by generating synthetic samples and make predictions on perturbed data using the original model, and weights samples based on proximity to the original instance. And then it trains a simple surrogate models and interpret the surrogate model to understand feature contributions. So it's available as a Python package called SHAP. It can be used with various model types, including tree-based models, neural networks, and others. So it provides a consistent and objective way to gain insight into model behaviors and feature influence, making it a valuable tool for machine learning. So there are trade-offs between explainability and model performance. More complex models like deep learning are harder to interpret, but often more accurate. And simpler models like decision trees are easier to explain, but may lack predictive power. So choosing the right balance depends on the application. Medical AI prioritize interpretability for safety. Recommendation systems may prioritize accuracy over full explainability. So there are ongoing researches focus on improving interpretability techniques for complex AI models. And regulatory bodies continue to enforce explainability requirements to prevent AI misuse. And AI explainability will be essential for ethical AI adoption in real-world decision-making. Next, let's explore the concept of sovereign AI. So sovereign AI can be thought of as a naturalized approach to AI, where countries aim to reduce their reliance on foreign technologies and ensure that their data remains within their borders. For instance, rather than depending on international cloud services or AI providers, a country might develop its own AI infrastructure for critical areas like healthcare, defense, and public services. So it includes data sovereignty, cybersecurity, and national security, and technological independence. So data sovereignty means that all data processing and storage are done within the country's jurisdiction. This ensures that foreign entities can't access or misuse sensitive data. For example, national health database that remain within a country's secure infrastructure. One of the key goals of sovereignty AI is to protect national security. For instance, AI can be used for real-time threat detection, monitoring potential cyber attacks, and safeguarding critical infrastructure, such as AI systems that monitor power grid to prevent foreign cyber intrusions. And AI sovereignty also includes to ensure technological independence. Country also seek it out to reduce dependencies on foreign AI providers. This helps foster local innovation and protect national interests. So developing proprietary AI solutions for urban planning, traffic management, and national defense are examples of achieving technological independence. So sovereignty AI also raised several ethical concerns that must be addressed to prevent misuse and protect civil liberties. While its goals may be well intended, the balance between security, privacy, and fairness is delicate and needs careful management. So, one of the biggest concerns with sovereignty AI is its potential impact on individual privacy and civil liberties. Large-scale data collection, often justified for national security purposes, can lead to mass surveillance and loss of personal autonomy. For example, AI-driven facial recognition systems used in public space may reduce crime, but also compromise privacy and track individuals without their consent. To protect citizens, government must enforce strong data protection policies and ensure that these systems are transparent and accountable to independent oversight bodies. And sovereignty AI system can be weaponized or misused by authoritarian regimes for social control, monitoring political dissent, or restricting freedom of speech. For example, censorship algorithms that suppress certain political narratives or monitor social media activities. So international cooperation and the establishment of ethical AI principles are crucial to prevent such misuse and promote responsible deployment. Another critical issue is the risk of algorithmic bias. Since AI systems rely on training data, any biases are present in that data can result in discriminatory outcomes, especially in sensitive areas like law enforcement or public service delivery. So, for example, predicting policing tools that disproportionately target certain communities based on historical data is an example of misuse of AI. So regular bias audits and the use of fairness-aware algorithms can help mitigate this risk and ensure that AI systems are fair and just. As more countries develop their own AI systems, there's a risk of global fragmentation in AI ecosystem. Countries might build isolated AI infrastructures that lack interoperability with global standards, reducing collaborations. Promoting global AI governance framework while respect national priorities can help balancing sovereignty with international cooperation. Finally, there's always a tension between security and innovation. Over-regulation can stifle AI research, while under-regulation can lead to security vulnerabilities. So encouraging public-private partnership can strike this balancing. and ensure security without compromising innovation. So sovereignty AI represents a powerful tool for governments, but it must be developed with careful ethical oversight to avoid misuses. By addressing issues of privacy, fairness, and global operation, we can harness the benefit of sovereignty AI while minimizing its risks.